Hey everyone, welcome back. Today we are going to break down Metasploitable 2. Now, if you have been in cybersecurity for more than 5 minutes, you have probably heard of this machine. It is an intentionally vulnerable Linux VM designed to be a punching bag for security training. We are going to go port by port, manually enumerating every service to understand exactly why it's vulnerable and how to exploit it. We are going from initial recon all the way to root. First things first, let's get our target up and running. I've got the VM booting up here, and there we go. The default credentials for this box are admin, MSF admin. We are in. Now before we switch over to our attacker machine, we need to know where this thing lives on the network. I'll run ifconfig. Okay, there is our target IP. 192.168.88.130. Make a note of that thing. Now that the target is live, let's jump over to Kali and start scanning. Alright, let's kick things off with port 21. This is the file transfer protocol. I'm going to run a specific scan on just this port to see exactly what version we are dealing with. Okay, look at that version. VSFTPD 2.3.4. If you have been in the game for a while, you know exactly why that's funny. But before we get to the heavy exploits, let's check for the low-hanging fruit, anonymous login. A lot of organizations enable anonymous access by mistake. Let's see if we can just walk in. I'll type anonymous for the name, and for the password I'll just type random. And we are in. We can now look around the file system. In a real engagement, you would be downloading sensitive config files right now, but we aren't done yet. Let's see if we can find some actual user credentials. I've got a small word list here with some common defaults. I'm going to use a tool called NXC to brute force the login. We found valid credentials for MSF admin service and user. The security here is, well, it's terrible, but remember that version? VSFTPD 2.3.4. That specific version has a legendary backdoor. In 2011, a hacker actually compromised the source code and added a smiley face backdoor. Let's exploit it. I'll fire up Metasploit. It connects to port 21, sends a username ending in a smiley face, and the server just opens a backdoor on port 6200. And just like that, we have a root shell. And just like that, we have a root shell. One last thing, if I were sniffing this traffic on Wireshark, I would see every single password in plain text. Always use SFTP instead. Alright, port 21 is down, let's move to SSH. Now, unlike the FTP port, SSH is actually secure by design. It creates an encrypted tunnel, so even if I'm sitting on the network with Wireshark, I can't see the passwords or the commands flying back and forth. The scan shows it's running OpenSSH. Now, older versions of SSH can have vulnerabilities, but usually the easiest way in isn't hacking the protocol, it's hacking the users. We are going to look for weak configurations, specifically easy to guess passwords. I'll use Metasploit's SSH login scanner for this. Or you can search by we set our target IP, and for the username and password, I am using that same word list file from earlier. Everything is set, let's hit run and start the brute force. We got 3 hits: MSF admin, service, and user. Just to be clear, the attack didn't succeed because SSH was broken. It succeeded because the users were lazy. They used default credentials and that let us walk right through the front door. Next up is the grandfather of remote login protocols, port 23. If SSH is the armored car of remote connections, Telnet is a postcard. Everything you type, your username, your password, your commands, it all gets sent in plain text. If I were an attacker sitting in a coffee shop on the same Wi-Fi as you, and you logged into a Telnet server, I could just open Wireshark and read your password right off the wire. But since we aren't sniffing the network right now, we are going to break in the loud way. We are going to hunt for valid credentials again. I'm going back to Metasploit. I'll search for Telnet login. Let's run it. And there they are, service and user. Now let's connect using the standard Telnet client and use the credentials we just found. And we are in. And the password user would be visible right there in the raw data. That is why we never use Telnet in production, always stick to SSH. Alright, let's keep moving. Port 25 is next. Alright, port 25, SMTP. This is a protocol that handles email. Now, modern email servers are pretty locked down, but older or misconfigured ones, like this one running postfix, are often way too chatty. They will literally tell you anything you ask them. We are going to check for two things here: user enumeration and spoofing. First, let's find out who actually uses this system. I'll use Metasploit to automate this. Basically, this model is going to knock on the door and ask, "Hey, is admin here? Is root here? Is Bob here?" And the server is going to answer. We just got a verified list of valid usernames. This is huge because now, if we wanted to brute force SSH again, we wouldn't be guessing usernames. We know these accounts exist. But let's verify this manually because it's way cooler. I'll connect directly using Netcat. I'll use the verify command followed by the user's name. This confirms the user exists. That is a massive information leak. Now for the fun part, spoofing. I'll introduce myself as hello attacker.com. The server, it doesn't care. It says hello attacker.com. I'll say the mail is from abc@attacker.com. Accepted. I'm sending it to root. Now I'll type the subject body. And I end it with a dot. Queued as. That means the server accepted the email. We just successfully spoofed an email from a fake domain to the root user without providing a single password. This happens because there is no authentication and no SPF or DKIM checks. Alright, that's enough email for today. Let's move on to something completely different. Port 111 and port 2049. Alright, we are moving on to something much worse. Ports 111 and 2049. This is NFS, Network File System. Think of port 111 as the receptionist. It tells you where to go. And port 2049 is the actual file server. It's like a shared folder on Windows, but for Linux. Now, NFS is great for sharing files, unless you configured it like this. I'm going to run Nmap's built-in NFS scripts to see exactly what is being shared. Look at this line. This is the smoking gun. The slash represents the root directory, the entire hard drive. The slash represents the root directory, the entire hard drive. The asterisk means everyone. So the server is literally saying, "Hey everyone on the internet, come look at my entire hard drive." Now let's confirm it with show mount. We have used E flag here. The whole file system is exposed. So let's mount it to our machine and take a look. I'll create a temporary folder. here on Kali, and then I'll use the mount command to link the target's hard drive to my folder. And we are in. I type ls and I'm looking at their file system. I can read their files, but can I write to them? I have checked the permission with find mount. Look at that first flag RW. This is game over. We don't need to crack a password. We can just create our own backdoor. Now, from an attacker's point of view, he will take his SSH public key and paste it directly into the victim's root user's authorized keys file. Now, the attacker unmount the drive to clean up and he simply SSH in as root. Boom, no password prompt. The server sees his key, thinks he's the admin and lets him in. We just went from scanning ports to full system compromise in about 3 commands, but we aren't done yet. Next, we are going to look at the Windows side of things, SMB. Moving on to ports 139 and 445. This is SMB, server message block. Usually this is for Windows file sharing, but here we have Samba running on Linux. Now, this allows the machine to share files and printers with Windows and computers. We see it's running an older version of Samba. Now, when attacking SMB, I like to think of it like an office building. First, you stand in the lobby and look at the directory to see what rooms exist. Then you walk down the hall and check which doors are unlocked. To check the directory, we use SMB client with a L flag. It asks for a password. I just hit enter and boom, anonymous login successful. We see the shares, print, TMP, etc. We know the rooms exist. Now let's check the doors. I use SMB map to check permissions. Look at the temp share. It says read, write. That is a writable share. We could upload files there if we wanted. If you want to be thorough or just lazy, you can use Enum for Linux. This tool runs every check in the book. It dumps users, groups, and shares and OS info. It's great for a set it and forget it scan. But let's get to the fun part, exploitation. This version of Samba has a vulnerability in the user map script. Basically, when you log in, it doesn't sanitize the username properly. We can inject a command right into the login field. I'll set up a listener on the left with NC LVP 1234 and on the right I connect to the temp share. Now I type logon, but instead of a username I type dismiss. See those backticks? I'm telling the server ignore the login and just execute this netcat command. Now I hit enter. Now we are root. We tricked the server into executing a shell just by typing a username. So that's SMB down. Next up, we are taking a trip back in time to the R commands. These are on ports 512, 513 and 514. Before SSH existed, Unix admins used these three tools to manage servers. Port 512 is regsec, remote execution, which requires a password to run commands. Port 513 is rlogin, remote login, which gives you a full terminal session kind of like Telnet. Port 514 is RSH, remote shell, which executes commands without an interactive login. The problem? These tools were designed for a friendly internet where everyone trusted everyone. They rely on trust relationships. We are going to focus on port 513 here. If a user creates a configuration file called .rhosts and puts a plus sign in it, the server will trust anyone from any IP without asking for a password. Let's check if that misconfiguration is active. I'm using Hydra and I have set the user list to my standard word list, but for the password I am leaving it blank. We are specifically checking for empty passwords. And there it is. Hydra confirms that root, MSF admin, service, and user all accept logins with no password. This is a massive security failure. Let's verify it. I'll use the native R login client and I'll hit enter. We are dropped immediately into a root shell. No exploit code, no brute forcing, just logging in because the server trusts us too much. So that's the R services. Now let's speed things up and look at the miscellaneous services. We have got Java. So that's the R services. Alright, let's look at port 1099. This is Java RMI, remote method invocation. Think of the RMI registry like a phone book. When a client wants to use a specific service, it calls this port to ask, hey, where can I find this object? But here is the problem. Older configurations are way too trusting. They don't just let you look up objects, they let you load new ones. We see it's running GNU class path RM registry. Basically, if I tell the registry, hey, load this new object, it will just obey. And if that object happens to be malicious code, the server executes it. Now, let's test that theory. I set the R host to our target and ran it. Metasploit sends a request saying, please load this class. The server downloads our payload, executes it, and sends us back a meterpreter session. Let's check GetUID and we are root. Again, no password cracking required, just a default trusting configuration. Moving on to port 2121. Now this is interesting. Standard FTP runs on port 21, so why is there another FTP server running here on 2121? This is a classic attempt at security by obscurity. The admin thought if I move the port number, the hackers won't find it. But as you can see, a simple port scan finds it in about 2 seconds. It's a flimsy disguise. We see it's running ProFTPD. So let's see if the admin at least used different passwords for this secret service. I'm going to use the same FTP scanner we used earlier. Exactly what we expected. MSF admin, service, and user. We found the exact same credentials here as well. This highlights the danger of password reuse. Even if you hide the door, it doesn't matter if the same key opens every lock in the house. Let's talk databases. Port 3306 is MySQL. Now, in a secure environment, your database should only talk to the web server, localhost. It shouldn't be chatting with the entire internet, but here it's wide open. We see the services running. Now, I want to check for a very specific, very common mistake empty passwords. Nmap has a built in script for this. And there it is. Root account has empty password. The database administrator literally left the front door unlocked, so let's walk in. I have connected using MySQL client and we are directly in. I want to show you the smoking gun configuration. I'm going to query the user table. Look at that host column for the root user. If it said localhost, we would be safe, but the percentage sign, there is a wildcard. It tells the server allow the root user to log in from any IP address in the world. That one little symbol is the difference between a secure database and a full breach. Next up is port 3632 running DistCC. This stands for Distributed C++ Compiler. Basically, if you are compiling a huge project like the Linux kernel, it takes forever on one machine. DistCC lets you split that work up and send chunks of code to other computers on the network to compile simultaneously. To make this fast, the default configuration usually has no authentication. It blindly accepts code from anyone, compiles it, and runs it. We are going to use that to our advantage. Instead of sending valid C code to compile, we are going to send a malicious shell command. For the payload, I am doing something different. I am choosing a bind shell. Usually we use reverse shells where the victim calls us. A bind shell is the opposite. The victim opens a new port on their machine, like unlocking a side door and waits. We just connect to that port and walk right in. We have a session. Let's check the host name. We are in. The server thought it was helping us compile software, but it actually just gave us control of the system. Alright, next up is port 5432. This is PostgreSQL. Think of this as a heavyweight champion of open source databases. It's powerful, but that power comes with risk if it's not locked down. Postgres has a feature that allows administrators to extend its functionality by loading shared libraries. On Linux, these are files that end in .so. Here is the attack plan. If we can log in with enough privileges, we can upload a malicious .so file, basically our own code, and tell the database, hey, this is cool, this is a cool new feature, run it, and the database will obey. Let's search this version on browser. Now, I'm not even going to set a password here. I'm betting on the default credentials, which are Postgres, Postgres. I set the target IP and my local IP for the callback and I hit run. Now watch the output carefully. See that? Uploaded as this. Metasploit just logged in, created a table, uploaded our binary payload into that table, exported it to the disk, and forced the database to load it as a function. Let's type getUID, and we are the Postgres user. Now this isn't root, but the Postgres user usually has deep access to the file system and configuration files, which is more than enough to cause serious damage. Now let's check port 5900. This is VNC, Virtual Network Computing. It's basically the grandfather of TeamViewer. It gives you full control of the mouse and keyboard. Here is the weakness. VNC often doesn't care about usernames, it just wants a single password. If that password is weak, we don't just get a shell, we get the whole desktop. Let's hunt for that password. And done. Look at the message success. The password is literally password. You can't make this stuff up. Now, for the payoff, I'll use VNC viewer and the target IP. I'll type password as a password and done. This isn't a command line anymore. This is full graphical interface as the root user. I can open terminals, browse files and change settings just by clicking around. Alright, one last port, the one that started it all. Port 6667 IRC. And finally, we have reached the last port. Port 6667 running IRC. Now this service has one of the craziest backstories in security history. In November 2010, hackers didn't hack the software itself, they hacked the official download mirrors. They replaced the legitimate source code with a modified version that had a hidden Trojan horse. So anyone who downloaded UnrealIRCd during that time, including the creators of Metasploitable, unknowingly installed a backdoor. The backdoor is hilariously simple. If you send a message to the server starting with the letters AB followed by a semicolon, followed by a command, the server just executes it. No password, no exploit buffer, just a magic word. Let's browse the version. For the payload, I am going to use a bind shell again. Also, you might see Metasploit give a warning about L host being unknown. This is totally fine since we are connecting to the victim, opening the door ourselves, so we don't need to tell them our IP. Let's hit run. Metasploit connects, sends that magic AB string, and boom, command shell session opened. Let's check who am I. And for the final time today, we are root. So there you have it. This is Metasploitable 2. We went from a blind port scan to compromising the system in over a dozen different ways. We exploited weak passwords on SSH and VNC. We abused trust relationships on RLogin and NFS, and we triggered backdoors in FTP and IRC. Now, if you want to try this yourself, and you definitely should, I have written a full blog post with every single command I used in this video. The link is right there in the description. If you found this helpful, drop a like. Thanks for watching, and I will see you in the next one.